All right, so Google Drive data sets. This data set I want right now is called Mindset Matters. So scroll down to the M's, Mindset Matters. And in week 1, I mentioned this data set. You may not remember. So Mindset Matters I found here. I want to open that up and make my own copy of it. Actually, if you made a special spreadsheet just for the crickets that we were working with, you could just copy some of the data into there if you want, or you could make a copy of the whole thing. I'm going to use only a few columns from this. Now, before I can do anything, I know a couple things here. 1, I know I have a spreadsheet in front of me called Mindset Matters. 2, I know there's a whole bunch of cases and variables, but I have no idea what those cases and variables mean, right? So next step is we have to go look at the data set description. So let's do that right away. So useful websites, data set descriptions, and find the one called Mindset Matters. There it is on page 59, it looks like. All right, what can they tell us about this? So data from a study of perceived exercise with maids. What does that mean? Going down to the details. In 2007, a Harvard psychologist recruited 75 female maids working in different hotels to participate in a study. She informed 41 of the maids, chosen randomly, that the work they do satisfies the Surgeon General's recommendations for an active lifestyle, which was a true thing, giving them examples about how and why their work is good exercise. The other 34 maids were told nothing, right? They were just put in the study. They said, we're doing a study of maids working. Various characteristics such as weight, body mass index, et cetera, from above were recorded for each subject at the start of the experiment and then again 4 weeks later. Okay, so for example, we'll have a weight and then we'll have a weight 2. So weight was right when they started the study, weight 2 was 4 weeks later. And some of the maids were told the work they do is actually good physical exercise, it's gonna make them healthier. And the other maids were told nothing. So they have no idea. BMI, body mass index, that's the ratio, what is it? The ratio of weight to height, I believe, which is one estimate of like how we might decide if someone is overweight or not. And so they have 2 measurements of that, the amount of body fat present, the ratio of waist to hip was the WHR. Original, we have systolic pressure, diastolic pressure, both before and after. So we have a whole bunch of variables. Most of these variables are quantitative. So we can pick a pair of quantitative variables and see if there's any relationship between them. So for example, would I expect there to be a relationship in adults between age and weight? Okay, so most of us, our weight is relatively stable throughout our lives. Doesn't matter our age. So if I graphed age versus weight, it would just be a cloudy mess of points. There shouldn't be a relationship. Now with kids, that would be different. As kids age, they get heavier. So with kids with age and weight, I would expect to see that younger kids are lower weights and older kids are higher weights, but adults are relatively fixed throughout their life. And we should just see a messy cloud of points. There shouldn't be any correlation between age and weight. Okay, how about weight and BMI? Well, weight is used to calculate BMI, so I should see some relationship. Somebody that is heavier is probably going to have a bigger BMI. Okay. Now, not always, right? Because somebody could be heavy and wide, or heavy and thin, or tall and heavy, or short and heavy. So there's a little variability there. But let's take a look and see what we see. So I am going to copy a couple of columns here. I'm going to copy the weight one. So I'm just going to click on the column. I'm going to choose copy, and I'm just going to go to that other spreadsheet I was working in. You could make a new tab in this spreadsheet if you wish. So here's my spreadsheet I was playing with the crickets. I'm going to add a new tab to this one, and I'm going to paste in weight there. And then I'm going to go back to that other sheet, Mindset Matters, and I'm going to grab the BMI, and I'm grabbing the first weight and the first BMI, not the second weight and the second BMI. So I'm going to highlight that column, copy it, And I am going to add that to my other spreadsheet, or if you're in another tab, that's fine too. Okay, so I'm wondering if there's a relationship between weight and BMI, and I think there ought to be. So I'm just gonna graph it and see. So to graph it, just highlight all of that data. And then insert a chart. So insert chart and see whether it looks like it's a cloudy mess or a slight linear trend. So it's a little cloudy, but I see an uphill trend here. Okay, so if you do see that there might be a pattern that you could draw a line through, then it's worth calculating the slope, the intercept, and the correlation for coefficient. Usually I do the correlation coefficient next. If the correlation coefficient comes out to be like 0.3, then I'm like, nah, nothing interesting here. So let's actually do correlation first. So I'm just going to move the graph out of my way. I'm not going to worry about making it pretty yet. And I'm going to go to say column D here, and I'm going to type correlation. And then underneath it, I'm going to do equals, start typing correlation. We want the correl function. And it says get your Y data first, comma, and then get your X data second. Oh, we were missing a number for somebody, and my columns aren't going to match up. I'm going to have to fix that in a minute. They have to be the same length. So I'm going to have to go back here where it says B2 to B60 on mine. And what do I want to extend that down? Down to 76. I'm just going to replace the 60 with a 76. The columns have to match. If they don't match, because they have to be points. Points need an X and a Y. So you got to make sure you got that. Because there was a blank, I tried to use Control-Shift-Enter to jump to the end, and I didn't notice it didn't jump to the end on the first column. So I'll just repeat it again. So I'll start over. You got to make sure the columns match. And this will happen once in a while because not all data sets have complete data. So I started off with equals, correl, and then the Y data, I need to make sure I get all the way to the bottom of the list. The first time I did it, there was a blank that stopped my Control-Shift-Enter. So I need to make sure I get all the way to the bottom. And then comma, get all your X's. I'm going to start from the bottom up there. Okay. And since I didn't select the header for the BMI, I'm not going to select the header for the weight. Does it matter if you select the headers? The answer is no. But if you do one, you got to do the other. All right, I get correl of 0.86, R is 0.86. Yeah, that's reasonably close to 1. So remember, that tells me two things. It tells me the computer sees an uphill trend, an increasing trend to these points, and that there's a reasonably strong relationship from one to the other, that it looks like weight could be used to predict BMI. Okay. All right, let's continue then. The correlation coefficient is reasonably high, close to 1, or could be close to -1. Let's find the slope and the Y-intercept. So the slope is slope. So equals slope. Highlight your Y's, make sure you get the whole list. And then comma, highlight your X's. And again, we got to get used to that. When we make a table, the table goes X, Y, but when we do the calculations go Y, X. So I get a slope of about 0.16-ish. Hopefully you found the same number. Intercept, Y's, and then X's. And then we'll figure out what these numbers mean. My intercept is about 2.8-ish. So I'm just going to blow that up a little bit. Do I need to see that many decimal places? No, I think I'll take the correlation down to maybe 5 decimal places-ish. 1, 2, 3, 4, 5. And the slope and Y-intercept, maybe I'll go with 3 decimal places on those. Usually the problem you're working on in the homework will say how many decimal places. All right, so now I'm just going to make a copy of those and try and explain this. And actually, no, I'm not. I'm going to go back to the chart. Remember, we can put the line in the chart. Let's play with the chart a little bit. And I got to zoom out to do that. Is it bad to have all that white space underneath the points? No, it's okay. But do you know, does it appear that anybody would ever have a BMI of under like 15? Doesn't seem to be possible in this group of people. So I don't necessarily need to see that. So sometimes when we're graphing points, we'll see 0, sometimes we won't. Do you think we're seeing 0 on the x-axis here? 100, 120, 140, 160, 180. Now the x-axis looks to be around maybe 90-ish for x, right? So the 0 that they show on the screen there is 0 for y. What is y here? Y is the BMI, yeah. So, all right, so what we're gonna do is we're gonna edit this just a little bit. We're gonna go edit charts, and then we're gonna customize. And the first thing I'm gonna do is show the line. So to do that, we go to customize series, and then scroll down to trend line and turn the trend line on. And then it'll draw a line through there. You can't easily have the line be a different color than the points. I have a way to trick the computer into doing that, but it's not worth the time to show you. And then for a label, I'm going to have it use the equation. Okay. And here it chose to round 3 decimal places on the slope and 2 decimal places on the y-intercept. That's okay. All right, let's put some better titles in here. BMI, right? I probably should label what that means. So I'm just going to replace it with body mass index. And then WT is kind of not a great one. I'm going to replace that with weight. And then I think BMI is okay on the vertical axis. If we want to be more clear, next to body mass index at the top, I could do something like parentheses BMI to kind of connect those. And then the WT, though, I think that's worth replacing with the actual word weight. Now, does everyone in the world measure weight the same way? Nah, some places use kilograms, some places use pounds. So we probably should verify that and put it in here. So let's see. That's on another screen. I think it's, yeah, since this was in the US, it's probably in pounds. So that's back here. Weight is in pounds. Yeah, yeah. All right, so I'm going to put pounds in there. Where'd it go? There it is. All right, so I'm going to put weight in pounds down here. All right, there we go. That's better. All right. And I'm just going to grab a screenshot of this sucker to draw on, and I want to talk about. Notice it doesn't show R on the graph, and you can't get R on the graph. So new page. All right, so just some things, a little bit of review of stuff we did before. Here I have a sample of, what was N on this data? 75 maids. So we have a sample. Of 75 hotel maids. Okay, what do you think the target population might have been? Now, I probably have to go read the whole article to get a sense of what they meant the target population to be. So let's see, they talked to maids at various hotels about the Surgeon General's recommendation of getting a certain amount of exercise to be healthy, right? And what it means to be healthy. So are they just targeting maids, or maybe did they have a wider audience of people who have jobs that has some physical activity to it? Yeah, it's probably bigger than just hotel maids. So we can just, without reading the whole article, we can only speculate on that. So I might say, and then the other thing is we haven't gotten to the whole gist of it. We'll look at that in a few weeks. But what they found was the maids that they told their work is good exercise and will make them healthier, they lost weight. They had better blood pressure than the maids that didn't know that. So what does that mean? It's not just the work you do, it's how you think about it. If you think what you're doing is healthy, then you will be healthier on average, which is kind of cool. when you think about it. Okay, so there were two things here. One, getting a good amount of exercise every day is important to being healthy, and two, thinking you're being healthy can matter too. Thinking the stuff you do does matter. On average, people will be healthier. Okay, so with all that in mind from the description, I'm thinking the population is probably kind of just aimed at really U.S. adults. Okay, so I think the population of interest is probably U.S. adults. Cases here are each individual made. In the sample. And the two variables I picked are quantitative, right? One variable, my X variable, was their weight, their initial weight in pounds. And the Y in this case is their body mass index. So now I want to figure out, what does this slope mean? And what does the Y-intercept mean? So first, let's think about the slope. And for me to think about slope, I have to remind myself that slope is rise over run. Rise in this case would be a change in the body mass index. So change in BMI. And the run here would be a change in weight. So change in pounds. And the slope I have rounded up here is 0.162. So 0.162, to write that as a fraction, I could just write that over 1. Now, it's a positive slope, which means both the numerator is positive and the denominator can be considered positive. Positive over a positive is still positive. So now I'm going to try and interpret that means. Now, the interpretation, does it start with the X variable or the Y variable? X. Why does it start with X? Because X is the explanatory variable. We're hoping that that weight explains why we might get a certain BMI. Okay, and weight is part of calculating BMI, so there ought to be some relationship here. Okay, so what this tells me, so the weight is in the bottom. So what this tells me is that if there is an increase from one person to another of 1 pound, I would expect the other person's BMI to be larger by about 0.162. Okay, so let's write that down. An increase in weight of 1 pound will lead to an increase in BMI of 0.162. Always? No, every point's different, but this is on average. Remember, a linear regression line is a special kind of average line. So on average. We could say, yeah, we could expect that to happen. Yeah. Yeah, so you got to put, so in statistics, we never know anything for sure. Everything is an expectation. Everything is kind of an average. Everything is about or approximate. It's never exact. Okay. Questions on that? So it's always, how does the explanatory variable affect the response variable? Okay, explanatory is always X, response is always Y. All right, Y-intercept. Y-intercept is a point. Okay, so I'm just going to sneak up here. Y-intercept is always the point 0, whatever B is. Okay, so B is 2.8. So that means 0, 2.8-ish. All right, X, that is the pounds. And the 2.8 is a BMI. So this says if somebody has a weight of 0 pounds, their BMI should be 2.81. Does that have a reasonable interpretation? No, you can't have somebody with no weight. Okay. Do we need that number? Yeah. If we don't have that number, the line won't pass through the points if we just ditch it. Okay, so in this case, the Y-intercept has no meaningful interpretation. And it turns out a lot of the time it doesn't. Every once in a while it does. So Y-intercept has no meaningful interpretation. Because having no weight means there's no person. All right, let's see. What we didn't talk about the correlation coefficient, except that the number looked good when we first saw it. What was that? See, we calculated that up here. We had a correlation coefficient of 0.86. 1 is as big as you can get. 0 would mean this is a cloud of nonsense. There's no relationship here, right? So 0.86, that's a reasonably strong positive correlation. And positive means that as one variable increases, so does the other, which the slope tells us also. So this just tells us the slope here is a meaningful calculation. Okay, so we have a reasonably strong positive correlation. All right, question. Let's do one. Okay, so let's try one where there's not a strong positive correlation. So, and again, that's kind of fuzzy. It takes further calculations to say it's really not a good correlation coefficient. But for us, we're going to say if it's above 0.5, we'll take it. If it's below 0.5, let's just forget about it. But there are some instances where I've seen a correlation of 0.3 and it turned out to be a meaningful relationship in slope. Okay, but second course in statistics, you'll delve into how to make that line less fuzzy. All right, so back to, where's that data? Here, the original Mindset Matters spreadsheet. Let's see, I mentioned that I shouldn't expect to see a relationship between age and weight because adults are relatively stable throughout their life. Let's see, weight and fat intake, or no, body fat. There's probably a relationship there. I might see a trend there. Systolic blood pressure. Do you think there's a relationship between weight and blood pressure? Think so? Let's take a look. All right, so I'm going to grab the weight column, put that in another tab or another sheet. Oops, wrong one, that one. So I'm going to make myself a new sheet again, put the weight in there, and then I'm going to grab the blood pressure, systolic, and I'm grabbing the first weight and the first systolic and put that in my new tab, new spreadsheet. Okay, and the first thing I do is I just graph them. Now, is it a big deal that some people don't have one of those measurements? The answer is no. When the computer tries to plot the points, it'll say, hey, there's no Y value, can't plot it. It's just going to ignore it. No big deal. So highlight all of those. And insert a chart. Okay, so does that look like a trend? Well, we might say that, hey, yeah, there's kind of a line going on there. Maybe a flat line, or is it a cloud? Okay, so I'm not really sure. I'm going to zoom in a little bit on it. It looks like I have no systolic below 100. I could double check by looking for the min. So I'm just going to go to customize vertical axis, and I'm just going to get rid of that white space below and put it at, I don't know, just to be safe, I think I'll put it at 95. So the other data was a little fuzzy, but a line was jumping out at me when I squinted. When I squinted this, I'm not really seeing a line I could draw. Okay, so the next thing I do is I could just say, well, this doesn't look worthwhile, but I usually do the correlation coefficient next just to check. So let's go up to the top and find the correlation coefficient. And equals correl, highlight your Y values, comma, highlight your X values. Columns have to match up. So I went from B2 to B76, so I have to go from A2 to A76. And I get a correlation coefficient of 0.2. That's pretty weak, meaning I don't see any pattern here. Visually, the computer calculated a very small, close to 0 correlation coefficient, so this is not worth pursuing. I'm done. Okay. For the activity this week, the application, I give you 5 data sets to choose from, but I don't tell you which variables to pick. You're going to have to look at the variable descriptions to say, I wonder if this variable and this variable might show a relationship. And sometimes you're like, yeah, look at it did. But sometimes like we thought there might be one here, but there's not. And so you have to say, oh, that won't work. Look at another pair of variables. There's going to be a little bit of trial and error for you to find a pair of variables that work for the next assignment. Okay, you just can't pick any 2 quantitative variables and hope something's going to happen. So if somebody had, turned this into me, the first thing I would say is you shouldn't have pursued these 2 variables. There's no relationship between them, no meaningful relationship. It's very weak. Okay, so I'm done with that one. So again, you might get lucky in this week's application where you pick a data set and you pick 2 variables and bang, it looks like there's probably a relationship there. But it might take a few tries to find one that looks meaningful to you. All right, let's see. We did residuals. We looked at cases where it does work and where it doesn't work. I guess we'll just do another example.